The following featured presentation is part of the Skywalking Network.
Today on Warsologies, we're going to talk to our expert, Angela Zoumplis, about extremophiles in a galaxy far, far away. That includes animals like tauntauns who live in cold weather, lava fleas who live on Mustafar, and also animals that live in the vacuum of space, like purgils and exogorths.
Star Warsologies is a podcast for Star Wars fans looking to connect real-world science, technology, and fields of study to the galaxy far, far away.
I'm Melissa Miller.
And I'm James Floyd, and we're both freelance writers for Star Wars Insider Magazine. All right, ready, Melissa? Punch it.
There's something alive in here.
Welcome to Star Warsologies. Our expert today is Angela Zoumplis, who's here to tell us about extremophiles. Angela, what is an extremophile and what makes you an expert?
Yeah, so extremophiles, right? So if we're breaking down the word, right, extremo means extreme, phile means loving, right? So these are organisms that love extreme conditions. And they're primarily what I study as a PhD student at Scripps Institution of Oceanography. You know, I get to look at these really cool things living on Martian analogs, in some of the coldest places on Earth.
So you're a fan of Star Wars. I know I've had you on my panels and as one of my expert interviews for a Star Wars Insider article about extremophiles. Can you tell us a little bit about how Star Wars influences your science and vice versa?
I had been a big fan of Star Wars for a long time. I remember they re-showed it. This was 1997, and I was about 7 years old, and they re-showed it in theaters. And so I went with my dad, and I was always fascinated with space, and to see all the cool, Star Wars universe and worlds and all the, creatures that were developed. And later realizing that a lot of these creatures had a lot in common with what I study now, which is a lot of adaptations to, again, space and extreme environments. So, yeah, it's influenced a bit of what I study, right? And then I also love looking at the, influence of biology and microbes and extremophiles on, perhaps what the writers or producers of Star Wars were thinking in developing these creatures.
Cool. What's one of your favorite extremophiles in Star Wars?
My favorite, and I got to chat with Melissa about this for her article that she did for Star Wars Magazine, the Minox. Those are some pretty sweet little critters. So the Minox appear in The Empire Strikes Back when Han and Leia and everyone, they land on the asteroid, and Han notices these creatures coming up and stealing the electricity from his ship. These are really, really neat. It's a neat concept, right? Because these are creatures flying around. They've got these like hair-like antennas, and they're stealing electricity from the ship, right? Which must mean that they are getting some type of energy or eating electricity off this ship. On Earth, we don't have any animals that do that, but we do have bacteria that will do that, which is
Really?
mind-boggling. Yeah. So there are these, extreme bacteria. They're called geobacter, and they have these hair-like antenna, and they eat electricity. Right, which is
how do they do that?
A little background on this too. We know a lot of life on Earth, right? Most life will consume food for energy. Some life, like phototrophs, will take in sunlight and they get their energy and they make food for themselves. There are other organisms that will rely on inorganic and organic molecules. But these guys, these geobacter bacteria, right, they have these little hair-like threads, just like you see in Star Wars on the Minox. They have these little thread-like things, and they basically pick up little electrons, right? If you stick an electrode in water and you come back a week later, there'll be these bacteria around this electrode just grabbing these electrodes, right? Grabbing these electrons directly, right? Without the need of any molecules or food, they are just grabbing electrons, getting energy, and then just spitting them back out. And so it's a pretty sweet, if you think of, again, what might have been coming out in terms of research in the 70s and 80s, this electricity eating bacteria was one of those new developments. So I'd like to think that, George Lucas or the writers were like, hey, you know what, this is really cool. Let's base this Minox around this bacteria and have all these thread-like, its mouth has all these little threads that would be good, almost like wires. It's almost like wires, you would imagine, getting electricity.
I do like to picture that too, sitting around in the writer's room or something like that, just hearing about some of this cool research and being like, ooh, yeah, let's work that in. So
Yeah.
especially because something like that does really sound like it's from a galaxy far, far away,
It does. Yeah. Yeah.
I noticed after you mentioned the electricity, I was thinking about what I call the space squid in Solo, but James knows the actual name of.
It's the Summa verminoth. It's that giant space squid you see in the Kessel Run that almost seats the Falcon, but they managed to jump out. But yeah, that thing is huge. Doesn't describe how big it is. It's massive on a scale that even the space slug isn't.
Right. And I also noticed when I went back and looked at some screen grabs of it, that it has this sort of like electric lightning bolts amongst its suckers. I know there are electric eels and they don't feed off of electricity, but they have some level of electricity. But it just made me think about if there was any corollary there.
Right. Yeah. I mean, a couple different things we know about, in light in general in the deep ocean, right? So, we do have these squids that are, bioluminescent and have all these little photophores, that are also, again, symbiotic relationship with the bacteria, right? I feel like most things I'll come back to just because, in general, extremophiles are tiny and microbial. But yeah, right. We know a lot of bioluminescence and photophores in the deep ocean. And then we also know, in terms of electricity, right, that, right, what you said, electric eels, that, same animals do use these as defense mechanisms or, so that is a cool biology grab from deep sea, but also animals that will use electricity for defense.
You and the Naboo form a symbiont circle. What happens to one of you will affect the other. You must understand this.
Yeah. And I mean, even just living out in the vacuum of space would lead this space squid and the other extremophiles to adapt differently in their biology. Is that right?
Right. Yeah. So the vacuum of space, oh boy, that's a whole nother ball game, right? So it's this and we were talking a little about the purgles. Is that what they're called? The floating whales in space?
Yeah, Star Wars rebels.
So it's funny too that the animals that we're bringing up are kind of like pests, right? So the Minox, are deterrents for the ship. These guys, I think the purgles will crash into ships, right?
They are viewed as a pest by some spacers, but basically they're just like whales accidentally bumping into ships on Earth. But if you stay out of their way, it turns out that they are sentient. They can bond with Ezra, right. And he kind of connects with them and even gets them to help in a battle. And then it turns out that they can generate their own hyperspace jumping capability, which is really cool. That possibly even inspired the other species in the galaxy far, far away to develop hyperspace, because hey, if purgles can do it, we can make something to do it.
Right.
And they eat, they kind of eat a gaseous soup that we see them at an asteroid kind of diving into a greenish gas that the gravity is holding in, that's being collected and harvested by the mining guild. So, it's competition for the food.
Yeah, I love that as well, right? First of all, that's adorable that they just kind of I thought just whales moving and they accidentally bump into ships. That's so cute. But yeah, we know a lot of metabolisms again. If you're talking about a gaseous cloud, right? So I was just talking about this not too long ago in 2002 was one of the first discoveries of organisms on life that could survive without organic material and without sunlight, right? So they are using gases. So these are called methanogens, and they were found in a hot spring underneath a mountain in Idaho. And so they are using just hydrogen gas and CO2 as their whole metabolism, right? So they get their energy from hydrogen gas and they deposit all that used up electrons onto CO2 and they produce methane. Right.
Wow.
And so this is it's a hypothesized metabolism for a lot of places outside Earth, right? That we don't need organic matter. We don't need sunlight, like a lot of sunlight or organic matter, but these organisms can survive just off of, inorganic gases. And so we've taken a hint here. And again, in the writer's room, I'd like to think that, when they were researching astrobiology and space, features that, a lot of these things probably came up. Can organisms survive off of gases, and yes, right. And maybe the size of a whale, who knows, that must be a very energy rich gas that they've made up. But it is a very cool idea, that was incorporated into these things. Yeah.
So these methane producing bacteria or methane producing microbes, how do they get the material to build themselves? That, they use hydrogen to get their energy, but how do they get the molecules to actually build their cells?
Right. That's a good question. Right. So Earth is abundant in, you need about 6 elements for life. Right. So we do have those elements just around. Hydrogen, carbon, oxygen, nitrogen, sulfur, phosphorus. We need all these elements on Earth to build life as we know it. Life as we know it is carbon-based, right? So we do need all these elements. And that's also, another thing, anytime NASA looks at any potential for habitability in terms of life as we know it, we're always looking for evidence of those 6 elements, right? So as long as those elements are there to build, a basic structure of life, then the metabolism of that life, can be, as far as we know, very diverse. And what they use for energy is sometimes mind-boggling. Carbon is what our life is based off of. And so one of my other favorite creatures, which again, we talk about in Star Wars Magazine with Melissa in her great article, is this exogorth, right? And that's
the space slug for everyone at home, that, the space slugs we see in Empire Strikes Back.
The cave is collapsing.
There's no cave.
What?
Yeah. So that's a really cool idea in itself, right? That when they land on this asteroid, inside this asteroid, they find this giant, right? It's like a space slug, basically, right? There was a research lab who pulled a meteorite and was claiming that there were cyanobacteria embedded in the meteorite, right? So, that was then questioned heavily because the pictures were a bit grainy and everybody wasn't really sure if that was what it was. Eventually, right, it kind of got disproven. But the idea that life could travel within rock and survive the vacuum of space in that way, right, that they would be embedded within rock. Cryptoendoliths. Endoliths means inside rock. Endo, inside, litho, rock. So it's cool, again, that, taking all these space references and studies that were coming out, that, we think that maybe life, if it is on other planets, can maybe spread that way, right, in rock or in asteroid, and then landing and colonizing. So it's already cool that it's embedded in this rock. But then another feature of this space slug that they had noted in the, Star Wars, I guess, reference guide here was that it was silica-based life, not carbon-based life. Silica-based life is also, it's a theory, right? If we're looking at other planets and we're looking at perhaps if carbon is rare on another planet and silica, is the basis of life, what would that look like? So they say that this slug is silica-based life form. Silica brings a lot of problems, right? It's a good idea, right? It's, carbon can bond with 4 other chemicals, right? And silica has that same potential to bond 4 other chemicals. So it's a little, on the periodic table, they look similar, but there are a lot of features of carbon that help us out. Like carbon is readily, can let go of those chemicals and bond with other things. So it's an incredibly kind of diverse, happy molecule that we have on Earth. But silica tends to really like oxygen, right? And so when silica binds to oxygen, it tends to make a really strong bond. And when silica forms this bond with oxygen, you get rock. That would be a bit tough to, have a silica-based life form. And then when you breathe out rock. But in areas of little to no oxygen, then silica might, potentially be a basis of life.
Yeah, and I remember thinking, even when I was younger and watching Empire, that the exogorth has these tiny eyes and these sort of little ear things, that it must be adapted. That's what they do. They live in these dark environments out in space where they don't necessarily need the same senses that you would need for life here, above ground on Earth.
Very cool. Yeah.
It now makes me wonder if space slugs, evolved in space directly, or maybe they were evolved on a planet and maybe that planet broke up or something. The microbes essentially on that planet just started getting bigger and bigger, or there were worm type things and, they adapted to space and, maybe their little eye stalks don't do anything now, but they're just little vestiges. Makes me wonder what else they eat because their mouths are so big. Obviously, they eat tiny little spaceships that fly in their mouths, but they got to be eating something bigger.
And would the Millennium Falcon have been a good meal? Was it going for the electricity of the Falcon itself, or any organic life forms that were on board? I'm curious about that now too. And how good of a meal could this have been? For something so big to rely on the sheer luck of something landing in its mouth is definitely very interesting.
Or maybe it eats aren't the Minox inside of it? The Minox are inside of it, right?
That's true. Yeah.
That would be handy as you grow Minox inside you, and that way you don't actually have to chew. You just keep swallowing and they just keep breeding in there as long as they have what they need, which is probably symbiosis. Yeah, they're probably, eating you from the inside. As long as you eat some rocks that I guess have the ions and electrons that the Minox want. Yeah. Now we got a whole theory going here.
Yeah, interesting. I still like the robot chicken of the Exogorth. The Star Wars ones are great. They actually did it in conjunction with George Lucas. But the Exogorths, there's like 2 of them, and they call to order Chinese food because they're so hungry because the Millennium Falcon got away. So they order all this Kung Pao chicken and stuff like that. It's very funny to me.
And then they want to eat the delivery guy too, so they're not worried about the tip.
Right, exactly. That's something I tried to sneak into that Insider article, and it didn't make the final cut.
The 20,000 pounds of Kung Pao chicken.
I did, because I was speculating on what they eat, and so I was like, oh, ships, this, Kung Pao chicken, but it got cut. So what are you gonna do? All right. So I know also, Angela, you mentioned that you study ice algae in Antarctica. Can you tell us a little bit about that and how it might relate to our favorite ice planet of Hoth?
Yes. So I do research in Antarctica, and we go down to the dry valleys, which is it's one of the largest ice-free zones in Antarctica. And it is that way because it's just so cold that any ice basically sublimates right into a gas. So it still has a bit of glacier ice, right? And during the summer, for about 4 to 6 weeks, it gets just warm enough where all this glacier melt starts to flow down, and you get these little streams, and they flow into these little lakes, right? Permanently ice-covered lakes, and they rehydrate these stream beds. And we see, for 4 to 6 weeks, really only, we see these cyanobacteria mats, so mats of algae. And we also find tardigrades and nematodes that will live off of that algae before going back into this dehydrated state for the rest of the year. So really, really cool extremophiles in that location and ice algae, right? We also study sea ice, algae that is living within the ice. They have special adaptations. They have antifreeze proteins, which basically stop ice from growing. They get secreted outside the cell, they bind to ice, and they stop ice from growing, forming these little pores for these algae to live in. So lots of really neat, adaptations in cold places. Especially that scene on Hoth with the tauntaun. Tauntauns are my favorite little critters. First of all, they're adorable. And second of all, they've managed to survive off of the lichen and ice algae on the planet. It is kind of a sad ending for the tauntaun, although it is, very helpful for Luke in the end. It also kind of reminds me of the first polar expeditions. That is so sad.
Sorry.
We just put up the skeleton inside the Wampa cave.
This reminds me of Antarctica a lot, right? So the first expeditions to Antarctica, there aren't any really bigger creatures on Antarctica. We find the penguins living on the coast, right, and whales and seals living on the coast. But when you get into kind of interior of Antarctica, we don't have any of these larger complex life forms, right? But in the early Antarctic days, they brought ponies, right? So they brought these Siberian ponies to Antarctica, and of course, these ponies unfortunately met their demise pretty quickly. Who knows? I'm not going to speculate that the early Antarctic explorers gutted these horses and lived inside of them, but one can speculate, I know that they did not do so well. Just like the tauntaun, they got a little bit overworked, and unfortunately, yeah, that's the horse story for Antarctica.
Well, it turns out Mythbusters tested putting a person inside a tauntaun to keep them warm theory, and they found out that it would work. That if you have a large tauntaun-shaped body that has its internal core temperature, you can put a human inside there, and that person will stay warm for a long time.
That's pretty awesome. So we're not telling the world that the early Antarctic explorers lived in these horses, but we could say that if you're ever in Antarctica and you just happen to have a horse with you and that horse dies, to maybe take your lightsaber, cut its innards out, and live inside of it.
It sounds like maybe it's not so realistic. Something as large as tauntauns wouldn't necessarily be able to live on the ice algae that you're talking about, at least based on the real world example of Antarctica. They're just not being large animals.
There's not, in terms of the productivity in forms of green plants or kind of the basis of a food web in Antarctica, it's pretty low productivity. So for anything really that is not a sea creature, right? Penguins get their food from the fish and krill in the Southern Ocean, but for anything that would live on land, there's not really a lot to support that life. And, we see this a lot, unfortunately, in the dry valleys where penguins come wandering in, and they just don't find enough to sustain themselves. So there are a bunch of penguin mummies and seal mummies out in the dry valleys that have been there for tens of thousands of years that happened to wander in the wrong direction and then couldn't find food or an energy source there. So.
The curse of the penguin mummies. I love it.
But I know that's a horror story I need to see.
Yeah.
That you did mention with the ice algae and stuff that there's tardigrades and nematodes chowing down on them. And so those are, multicellular forms of life that, tell us more about tardigrades and nematodes for those who don't know.
Yeah. So that is, again, more inland Antarctica, that is kind of the most complex life we see out there, right? Are these tardigrades, which are also known as water bears or moss piglets. They just sound cute, and they are very cute. For somebody who looks at microbes all day, it's a big change from bacteria to see these cute little, they almost look like bears. They have little claws, right? They hibernate over the winter. They're very cute. They are tiny little microbe bears. So, right, nematodes, we also find these things called rotifers, and they just look like little alien creatures, right? Rotifers also have this kind of spinning jaws. Tardigrades have claws, right? So it is kind of rough life in the microbial world. They tear apart their, algae. Fortunately, there's, they're mainly, I was about to say they're mainly herbivores, right? But they can, eat each other as well. They are very tough, hardy animals, micro animals, that is. But yeah, they are very cool. And, of course, tardigrades are known to a lot of people to be able to survive and withstand a lot of extreme environments, including the vacuum of space, right? So I think there was a project on the ISS where they exposed tardigrades to the vacuum of space, and they found that they dehydrate themselves, right? And they slow their metabolism. They can slow their metabolism to 0.1 of metabolic activity. They are incredible in terms of what we might see on another planet. Tardigrades are quite up there.
Wow, that is amazing, because a different franchise, Star Trek and Star Trek Discovery, had space tardigrades that they started to capture, and I think some of them went on a rampage on the ship. But to hear that there are tardigrades that survive in space and just slow their metabolism down, as long as they don't get big, we're okay. Right?
Yeah, they are scary. I mean, it's fortunate that they are, they're cute because they're tiny and microbe sized. But if they were bigger, they would be some pretty fierce little guys walking around. But we talk a lot about tardigrades surviving. The key word here, though, is survive. They don't necessarily thrive in these conditions, but tardigrades are kind of something that we could see almost like the exogorth kind of hiding out in, an asteroid. They can survive, right? They dehydrate themselves. They reduce their metabolic levels to almost, nothing, and they wait for better conditions, right? And then they pop up. So, it's survival versus thriving, but these guys are able to survive in some of the harshest, right? These are some of the harshest conditions we could think of. Maybe they colonize other planets like this. Maybe this is a mechanism for a colonization where you can survive for hundreds of years just in this little dehydrated ball. And then when things get better or you happen to land somewhere great, you just pop back up and start, living.
I wonder that about the exogorth then, if, it was in some sort of hibernation state and then blaster fire or even just the ship flying into it. Somehow woke it up.
Yeah. And there are a lot of, there are a lot of sea creatures like this too. The deep sea in itself is fairly low in organic matter. And there are places in the deep sea where, you do see this rapid colonization very quickly. For the most part, animals have, I imagine, fairly slow metabolisms in the cold, right? But you do see these kind of opportunistic feeders sometimes, and this is shown in like whale falls and other places where you just have this all of a sudden input of something awesome, and then everything springs to life, right? So yeah, you have a slow metabolism, but then big chunks of food fall down. They get enough energy, and
then they wait for the next piece of meat to fall down.
Right? Yeah.
What you mean by a whale fall is a whale dying and just its whole body sitting on the bottom.
Yep. That's
it's exactly raining meat.
It's raining, raining whales. Yeah.
Yeah, I guess I have seen those pictures or those videos where after only a few weeks or something like that, it's just all bones. And there are also worms that eat bones, if I remember correctly, because that is all that's left.
Yeah. Greg Rouse at Scripps has made an awesome career off of looking at these bone-eating worms that just happen to find these whales. I guess they're just, again, it's kind of like waiting for this food to drop and then, rapidly colonize and then can digest whale bone, which is, again, bizarre if you're looking at different life forms and what things eat.
Makes me wonder, what happens to dead purgils if they die somewhere and there's worms that can eat through purgle bone.
Yeah, that would be interesting. Just a dead whale floating through space. and then all of a sudden you got these bone-eating worms in space. Interesting.
Yeah. I mean, there's a niche for everything, right? So are there any other real world examples that sort of tie back to Star Wars or any other particularly cool Star Wars creatures you want to talk about while we have you?
I would say we can shift to the hot stuff.
Go to the Mustafar system.
The lava fleas, right? So there's that
Mustafar. Yeah, at the end of Revenge of the Sith, they go to the lava world of Mustafar, and then later on, Vader builds his castle there, and we see that in Rogue One.
So they really tackle a lot of different worlds and extremophiles out there, right? So we've got the cold planet, we've got the hot planets, but this is pretty neat. This lava flea, it's all built up in armor. Which is really, really neat. So what we know of thermophiles, right, they have to have a very kind of rigid cell, and they do have these, molecular structures that stabilize themselves in high heat. Disulfide bonds, help kind of stabilize membranes. But yeah, these things just look awesome. I mean, they're all covered in armor, very neat. And then the Mustafarians themselves, I think, are, have this kind of tough, what they say is exoskeleton. Very, very cool, that they thought of these neat adaptations. And so, we know of thermophiles on Earth that can thrive in, upwards of 100 degrees Celsius, which is the boiling point of water, right? And so we know of microbes that are surviving at 120 degrees plus. Wow. And some of these, are thought to be the earliest known microbes on Earth, because, once Earth was this kind of hot lava-y planet with very, very high temperatures. Astrobiologists care a lot about, thermophiles in that regard, that, these may be some of the oldest and hottest microbes. Very cool. I remember reading that in the Star Wars, these lava fleas, they built these tubes, which is very reminiscent of what we'd see on Earth called a lava tube cave, which is a natural occurrence, right? And there's some, I think they're in New Mexico, that you can go into lava tube caves, not built by lava fleas, but just a natural occurring lava tube cave on Earth. And so if you're looking for the Star Wars experience, lava tube caves, I guess I'm plugging lava tube caves. Maybe we can get this podcast sponsored by Lava Tube Caves.
Lava Tube Caves. Come visit us. But it gives me my favorite Scrabble word, which is also one of the first words in the dictionary. Just AA. It's a lava tube.
And James does some traveling to Star Wars filming locations, but maybe you should add Star Wars inspired locations to your list too, and go to some lava tubes and pretend you're on Mustafar.
There we go. If somebody out there wants to send me to Hawaii to look at lava tubes, I am available.
Nice. It's a hard job. Someone's got to do it. I don't even know that I noticed, honestly, the lava fleas until you pointed it out, James. I had to really search my mind for the memories of that in episode 3. So
yeah, they're just very background. So you mentioned that there's a lot of bacteria that are these thermophiles. Are there any multicellular thermophiles?
Not that I know of yet. And most of the thermophiles that I know of are archaea. So not even a whole lot of bacteria, but mainly archaea, which is a subgroup, right? In the domains of life, we have archaea, bacteria, eukaryotes.
Oh, wow.
And so very, very early looking kind of basic, simple organisms that just have persisted from potentially early Earth when it was all a big, hot, lava fireball to what we have now. Most of these things are pretty tiny. We know insects are very tough. And so I know that, lava fleas and even the Mustafarian are kind of these insectoid creatures, but not that we've seen necessarily in on Earth as in hot springs or around volcanic systems.
Angela, can you tell us a little bit about your career path and how you originally got interested in this field of science?
Awesome. Yeah. So I started out, junior year of undergrad. And I knew I was interested in science and I didn't know which kind of science. And so I just applied for a ton of internships. In the end, I happened to get one, and that was at NASA Ames in Mountain View, California. And they put me in the astrochemistry division. I had absolutely no idea what I was doing. I knew nothing of space, but being surrounded in that little NASA culture with all these scientists, constantly talking about the potential for life on other worlds, you really start to believe it, and it gets really interesting. So we would freeze all these chemicals and then look at their signatures to plan for the mission that was being sent up to look at different ice mixtures on other planets. And so that got me interested in, all different types of icy worlds, right? And then the potential for life elsewhere. And now I'm at Scripps. Scripps is primarily an oceanographic institution. My advisor, fortunately, kind of let me run wild with this Dry Valleys project, kind of the opposite of oceanography, really. But I'm thankful he did. But also, the deep sea is very, very cool. And one day in the future, hopefully, more deep sea stuff. But, at Scripps, you get exposed to a lot of very cool environments, in the ocean as well. And those are also fascinating: methane seeps, hydrothermal vents. And so that's on my list next. I get highly influenced by internships, and where I'm at, I guess, really is very influential. But for anyone, wanting to go down the science route, the more internships or the more research that you can do in different fields to really figure out, which one interests you. And sometimes it's as simple as an email to a professor, or, just finding those emailing the heck out of people, and seeing they have opportunities. And then, some things that you don't even think you might enjoy, you might find really interesting. So.
Well, where can we find you? Do you have any upcoming publications, or where are you on social media these days?
Yeah. So I'm on Instagram, Twitter, and gosh, I hope the publications soon. I keep telling my advisor that, the publications are going to be really soon. We are working up a couple papers on these Antarctic projects, especially in the dry valleys, right? So community diversity, and hopefully those will come out, within, the next 6 months or so.
What are your Twitter and Instagram?
Oh yeah. It's just my first and last name.
Zoumplis.
Yes, that's awesome. Okay. Yep, Angela Zoumplis. Yep.
Well, thank you so much for joining us, Angela. It was great to talk to you and hear about your expertise, and also about how many times in the Star Wars movies and TV show extremophiles show up.
Awesome. Yeah, this is a fun chat.
Yeah, thank you so much.
Yeah, thank you guys.
If you have any questions about what we talked about today or want to ask a question to Angela, just send us a line. Got an idea for a topic? That also works as well. Know an expert that would love to be on the show that's a big Star Wars fan? You can reach us at Star Warsologies on Twitter and Instagram, or at starwarsologies@gmail.com. That's Star Wars OLOGIES.
That's it for this episode of Star Warsologies. We want to thank our guest, Angela Zoumplis, and we want to thank all of you for listening. We are part of the Skywalking Network, where you can also find a variety of other great shows like classic Marvel Star Wars comics, the Max FX podcast, the Neverland Clubhouse, Totally Tell Me Everything, and the flagship show Skywalking Through Neverland. You can find all of these shows at skywalkingnetwork.com. And look for us at Comic-Con at Home 2021, where James and I will be moderating the panel, The Science of Star Wars.
Join us next time on Star Warsologies when we talk to an electrical engineer about the Mars Ingenuity helicopter and how it relates to Star Wars.
Thanks so much for listening to our podcast. Don't forget to like, comment, and subscribe.